This is Applied Superconductivity Center here at the National Magnet Field Lab. We're actually across the street from the main building. My name is Ernesto Bosque. I work here at the Applied Superconductivity Center, which is across the street from the main building of the Magnet Lab. What we have is the Deltec room, and this is a furnace which isn't part of the normal tour. ASC is actually a bit further away from the main lab, and this is kind of our dungeon room, really for processing BISCO wires, 2212 actually, bismuth, strontium, calcium, copper oxide. Now this is a very special furnace. There's only about 2 of these type furnaces in the world for processing high temperature superconductors. One of them is a private company. It's a massive system. This is a very research development furnace. And what we can do with this is we can increase the pressure of the inside hot space to about 50 atmospheres. We typically live in about a 1 atmosphere environment, Earth. So we increase the pressure up to about 50 atmospheres, and we drive the temperatures up to about 900 degrees Celsius. So very, very specialized furnace. And the reason we do this is for the processing of, like I said, BISCO 2212, wherein you start with silver wires with micron-sized tubes in them. You fill them with powder, and the issue with heat treating 2212 is that gas that's inside of those tubes will expand when you heat them up. So the idea of putting overpressure around those wires is that you compress that and make sure that gas can't expand. Now the temperature excursion up to 900 degrees, that actually melts that powder into these filaments, these long strain filaments. And then what you get out of the heat treatment, once we cool back down, is this wire with long ceramic strands, which is the superconductor, which is the superconducting part of 2212. So what we have is about a 5-inch diameter, about 24 inches of hot zone, pretty much right around here inside of the furnace, that we can process coils of, fairly substantial size. We're targeting somewhere on the order of about an 8 Tesla insert magnet that we'll put into outsert magnets down the line. Now, past that, like I said, one-of-a-kind research development furnace. We have many collaborations around the world. We're working with CERN in Geneva. We're working with Lawrence Berkeley National Lab. And we also have a collaboration with Fermilab as well. Is it Fermilab? Might have to cut that. Yeah, and all of our internal research as well. We do a lot of the prototype coils. So we'll design coils to fit into existing magnets, and we will just test the performance of 2212. We're pushing this technology to become a mainstream high field magnet application. And particularly for the NMR community, so nuclear magnetic resonance, think MRI science grade. So that's kind of the focus of the HTS coil group here, and this is kind of the invaluable part that the processing that makes it all possible, really. So now that we have the furnace open, this is essentially what we work with. The inner space is about yay big, 5-inch in diameter, and we have a multitude of thermocouples inside so that we can actually take temperature traces throughout the entire process. And with that, we can balance and tune the furnace, and we can heat treat these coils to within about a degree differential across an entire coil through the whole heat treatment, from room temperature all the way up to about 900 degrees centigrade and back. We'll have a differential of about no more than about 1.5 degrees or 2. So again, pretty high precision research development furnace. Yeah. So.